Okay, we are gonna hopefully we'll finish this today in class. So we're at number 12, and it says write out the binomial expansion. So here you go. This is about as basic as it gets right here. Okay, I could have made it a little more complicated. I could have said like 2x squared plus 3y cubed or something like that to the fifth, and that would have been a little bit more complicated. This is just straightforward, just to see if you really know how to do this. Remember to do that Pascal's triangle? Remember that thing? So let's do that. Remember you had a 1 on the top, and you just keep on going down like this. Right? So you got a 1 and 1 here. So what goes here on the end? 1's always go on the end, right? And then what goes in the middle? What do you do to those two? You add them up, and then a 1 goes on the end. Good. So you got the hang of this thing, right? So let's go down. Since this is to the 5th power, we're going to go, that's to the 0 power, to the 1st, to the 2nd, 3rd, 4th, 5th. So we'll go down to the 5th. Right? So we go 1, and then 3, 3, and then a 1, then another 1. You add those up, that's 4, 6, 4, and 1. And do it one more time, right? 1, 5, 10. Good. Alright, so that only takes a few seconds, doesn't it, to figure that out? Because I really don't have these memorized. I guess you could memorize these across, right, for whatever exponents you're going to do. But it only takes a few seconds to do this, so I'd go ahead and do that if I were you. Alright, so which one are we doing? Which one of these are we using? Yeah, we're using this one right here. And what do those numbers show you? What do they indicate? Why are they useful to us? Because they're the what of our... It starts with a C. I use this word quite a bit. It's called the coefficient. That's right. These are coefficients of each of these terms. Okay. Look, you got 1, 2, 3. Actually, you got 6 terms, don't you? 3, 4, 5, 6. That is right, isn't it? To the 5th, we go to the 5th. Okay, all right, just making sure. But there are 6 terms here. So let's see, what do we do? First coefficient is a 1, and then we do what? X to the 5th. Now, technically, you do have a y there, but what is it? It's y to the 0, isn't it? You don't. I wouldn't put the y there, but technically it is. It's y to the 0. So what happens to the x to the 5th? Each term does what? What happens to that 5? It goes what? Goes down, and that y to the 0, technically there is a y to the 0 there. What happens to that? It goes up, okay, on the next ones. And then the coefficient in front of every one of these terms are these numbers right here. Does that make sense? Okay, so now we just go 5, and now what happens to our x? That goes down 1, so it goes to x to the 4th. Remember, this was y to the 0, so it goes up 1, so it's y to the 1st. And now, if you just learn the pattern, it's pretty simple, to tell you the truth. I think, don't you? There's really not a whole lot of math you have to do with this particular one. So the next coefficient is a 10, and the x goes down 1, so it goes to cube, and the y goes up 1. So the x goes down, the y goes up. Plus, and then you got another 10 there, so that's our next coefficient. The x goes down 1 more, and the y goes up 1 more. Then your next coefficient is a 5, and then your x goes down 1 more, just x to the 1st, and your y goes up 1. And then coefficient is a 1. The x goes down. Now this was x to the 1st, right? So it goes down to x to the 0. But what's x to the 0? It's just a 1, isn't it? So x to the 0 is a 1 times 1. So we don't really need an x there, do we? Alright, so this goes up 1. The y goes up 1 to the 5th. And then we're done. That's it. That's all there is to it. It's a pretty easy way. It's kind of like a simple way to multiply all this out. If you didn't know this thing, you could still do this. But what would you have to do? It's not just x to the 5th plus y to the 5th, is it? It's a lot more than that, isn't it? Right, 5 times, right? So look at this. If you didn't know this way, you could always do this. And that would be a real pain, wouldn't it? That'd be a lot of work. What would you do here? You'd FOIL this, right? Then take that answer and multiply it by this. Take that answer, multiply it by that. Take that answer, multiply it by that. Okay, so there's like 1, 2, 3, 4, 5 distributor properties you would have to do here. Each one getting more complicated and more complicated because there's more terms. But if you did that, you'd eventually end up with this thing right here. But this little trick, it's kind of like a little trick, I guess, a little method, that's way easier than doing all that stuff. Okay, so I think you can appreciate why it's nice to learn this thing. Alrighty. That was number 12. So that wasn't so hard. I mean, that was a crazy looking answer, right? If I just looked at that answer, I'm like, there's no way I could do that. But I think after you see how to do it, it's not so bad. Okay, division. This says to divide. So we're going to do this by long division. And I'm not going to give you real complicated ones, okay? All these are pretty basic, okay? I mean, I could have given you a real difficult division problem, but I made this pretty simple. And on the exam, midterm exam, you know, I'm not going to make it any more difficult. So, like, the level of difficulty is not going to increase, all right? It's going to be pretty much the same as far as the level of difficulty with these problems. I made this pretty simple. So we do this by, oops, why did I put a 5 there? Don't know. We do this by long division. So we set it up. Alright, so there we go. And now we work this just like a regular long division problem. Okay, if you don't remember, you know, like why we do what we're doing, go back to the lesson where we taught this. It goes way back. And you can you know, you can review it if you want. But let's just do it very quickly. We say x. We just take a look at this x, not the whole x plus 4, just the x right here. And we say how many times does x divide into, or go into, we say a lot of times, x squared. Well, it's just the same as saying x squared divided by x, isn't it? And what is x squared divided by x? It's just x. So x divides into x squared x number of times. And now what do we do with these two? I like sometimes to put this in parentheses so it reminds me to distribute it through this whole thing. I always put a minus sign right here because we're going to subtract it and then we multiply. So I've got x squared plus 4x. Alright, and now we go ahead and subtract. Notice what I've done. I put parentheses around this and I put parentheses around this. Everybody see that? And so it's x squared minus x squared, which is 0. 11x minus 4x, 11 minus 4 is 7x. Then I start the routine all over again. I say, and let's bring down the next number. And then we can start the routine all over again. We say, how many times does x divide into 7x? Or you could look at it as 7x divided by x. So if you go off to the side and go 7x divided by x, look what happens. The x's cancel, and it goes what? 7 times. It's positive 7, so we put a plus there. If you happen to have a negative in there, and this was a negative 7, you'd put a minus 7 up here. Alright, so we put a minus. I like to put this in parentheses, and then we distribute. 7 times x plus 4. So that would be 7x plus 7 times 4 is 28. And then subtract. 7x minus 7x is 0. 20 minus 28 is negative 8. Bring down the next number. Well, there is no next number, so guess what that thing is? That's my remainder, isn't it? Because x doesn't divide into negative 8. So that's my remainder. How do I write my remainder? I don't. Well, it's a negative 8, so I'm going to put minus
8 over x plus 4.
Good. Yep, just like that. And that's your answer right there. Don't put a r for remainder. That's kind of like an elementary way of doing things. So we write it as a fraction. Negative 8 over whatever we're dividing by, x plus 4. It's not so bad, is it? Is it coming back to you? All right, practice it a couple times, though. Practice it. Now, you guys, we don't use the book very often, you know, to do problems from, but the book's a great resource for you because the odd answers to most of the problems, not every single one, but most of the ones you probably would pick, the odd answers are in the back. So go to this lesson. Find a problem that looks similar to this, and you'll find a handful that you can do, and the answers are in the back, and it's good practice. Okay. You gotta practice. That's what math is all about. It's not about sitting there and listening to my explanations. It's about doing it yourself, okay? Practicing. All right, number 14. Let me pause this while I write down the problem. Okay, here we go. This problem right here, it says to factor the greatest common factor. I'll write that down. Factor the greatest common factor. All right, so what we do is we look at, there's 3 terms here, aren't there? Here's the first term, the second term, and the third term. What we're going to do is find out what is in common. What is the largest thing? What's the most stuff that's in common with all 3 of these terms? Okay, so I've got 160, I've got 64, and I've got 32. That might not be something you can do right in your head. I don't know, maybe it is. I don't know, does 32 go into 160?
Yep.
Does it? Okay,
5
good.
times.
Yeah, and I know 32 goes into this, and I know 32 goes into 64 twice, right? So yeah, that works out pretty nice, doesn't it? Right? So 32 divides into all of those evenly. So that's a greatest common factor. So that's with my numbers. What about the letters? I got x to the 8th, x to the 5th, x to the 3rd. Which one is in all three of them? X to the 3rd is in all three of them. X to the 8th is not in this one, is it? There's not enough here. There's not enough here for x to the 8th to divide into that evenly. But there is an x to the 3rd in every one of those terms. So that's my greatest common factor with the x. And then the y's. I got y to the 9th, y to the 6th, y to the 4th. It's y to the 4th. So that's the greatest common factor. But it says factor it. It doesn't just say find the greatest common factor. It says factor the greatest common factor, which means I got to figure out what's left over after I factor this out of all three of these terms. Okay? When I factor it out, when I say that phrase, factor it out, it means we're going to divide it. We're going to take this first term, we're going to divide it by our greatest common factor to find out what's left over. Okay? So I just take each of these and divide it by this greatest common factor. So 160 divided by 32, and I think that's 5, isn't it? Okay? That's 5. Then I go x to the 8th. X to the 8th divided by x to the 3rd. Remember the rule for division with exponents? We subtract the exponents, right? And so that would be x to the 5th. Then the y's, y to the 9th over y to the 4th, we subtract the exponents, that's also y to the 5th. So that's the first term. Now I take the second term and I divide it by this stuff right here. So it's plus 64 divided by 32 is just 2. X to the 5th divided by x cubed is x squared. Subtract the exponents. Y to the 6th divided by y to the 4th is y squared. Everybody good so far? Pretty easy, right? 32 divided by 32 is 1. Okay, keep that in mind. X cubed divided by x cubed is 1. So far we have 1 times 1, which is 1. Good. So when you go home tonight and your parents say, what'd you learn in math today? Well, we learned 1 times 1. All right. So what about this one? Y to the 4th divided by y to the 4th is 1. So I've got a 1 times 1 times 1, which is 1. So what do I have to put here?
-1.
A 1, right. I've already got the minus, but I put a 1 right there. A lot of people leave that blank. You can't leave it blank because this thing right here, this third term divided by your greatest common factor comes out to be a 1. You must have the 1 there. What's an easy way to check this if you really wanted to? Distribute, that's right. If I didn't have a term here, if I didn't have anything here, then this is all I would have is 2 terms. Is that the same as this thing up here? No. So I have to take this and multiply it by a 1 in order to get this. All right, that's an easy way to make sure that you have enough terms in your answer. It's a very common mistake that people don't put anything here. They think, oh, it cancels out, just goes away. I don't have to write anything. No, you got to put a 1 because it all divides out into to be a 1. All right? All right, we're moving right along. Any questions, let me know, okay? Okay, another factoring, but it's a little different type of factoring. All right, we've got another factoring, but we're going to do this by grouping, factor by grouping. So if you look at this, there is no greatest common factor with all 4 of these terms, is there? I've got a 10, 4, 15, and 6. Is there anything that divides into all 4 of those numbers? No, there's not. Okay. What about the a's? Well, I got an a cubed, a squared, a, but I don't have an a here. Can you factor out an a from all 4 of the terms? No, you can't. What about the b's? Well, there's no b here, but there's a b here, here, and here. So there's nothing in common with all 4 of the terms. All right, so I can't do a greatest common factor. So what I'm going to have to do is I'm going to have to group them together. All right. So let's take, yeah, that's a good idea. Let's take the first 2 terms. Let's group them together. Because look, is there a greatest common factor with the first 2?
Yes.
Yeah, there is, okay, because there's a number that does go into 10 and 4. I've got a's here. Now, there's not a b, but there is a greatest common factor, though, that I can figure out for those 2. And then what about these right here? Is there a greatest common factor with this? Absolutely. So let's see what we get here. Let's just do this first parentheses. Let's just do greatest common factor. I got a 10 and a 4. What divides evenly into 10 and 4, the largest number?
2.
Just 2, right. 2 is the only thing. Okay, 4 doesn't go into 10, so 2 does. What about the a's? I got an a cubed and an a squared. A squared. What about b's? Is there a b that goes into both of those? No, there's not. So that's my greatest common factor for just this parentheses. So it's kind of like we're doing this problem right here, but we're doing it twice. we're doing it for just 2 terms here, and then we're doing it again for these 2 terms. Does that make sense? So let's see what we get. A factor out of 2a squared. How do you figure out what's left over? You divide, just like we did before. 10a cubed divided by 2a squared. Well, 10 divided by 2 is 5. A cubed divided by a squared is a. Minus 4 divided by 2 is 2. A squared divided by a squared is 1, but then you have a b, so you got to put a b right there. So that's the greatest common factor. That's all we did. We found the greatest common factor of this group of terms. Okay, let's do the same thing for this right here. There's a plus in between, so put a plus right here. Let's figure out what's the greatest common factor with this. 15 and 6, what divides evenly into both of those? 3 does. What about the a's? Well, there's no a in both of them, so I can't put an a here. What about the b's? B squared. Let's figure out what's left over. We take this and divide it by a greatest common factor. 15 divided by 3 is 5. Now there's an a here, but there's no a here, so I got to put an a. And then b squared divided by b squared is 1. So I just keep it like that. Put a minus, because you got a minus right there. 6 divided by 3 is 2. B cubed divided by b squared is b. Now look at this. Now they've kind of rigged these, don't you think? Where this also, we're going to do greatest common factor one more time. So look at this. We'll do greatest common factor 3 times on this problem, not just once. We did it once here, and now we're going to do greatest common factor here. Because if you look at this, this really is acting as one big term. This one right here is acting as one big term. Got a plus in the middle. Everybody see that? So is there something in common with this group and this group?
Yep.
The 5a minus 2b, that's right. So that's in common. 5a minus 2b is the greatest common factor with both of these terms. Let's figure out what's left over. How do we figure out what's left over? We take this and we divide it by 5a minus 2b. So if I took this and divided it by 5a minus 2b, they would cancel out, and what am I left with? Just a 2a squared. Put a plus. Let's take this one divided by our greatest common factor. Well, they would cancel out, and what am I left with? 3b squared. And that's my answer right there. I can't factor this thing anymore, can I? There's no greatest common factor. There's nothing I can do with that. So that's my answer right there. Okay? Don't start multiplying. I've seen people do this. They get to this and then they start multiplying it through. Like, oh, I got to simplify it, so I might as well do FOIL method. But guess what FOIL method is going to give you? It's going to give you back to where you started, right? So you went in one big circle. Okay, that's not what they're asking you to do. They're asking you to find the factors. And these are the factors. It's this thing right here times this thing. Those are the 2 factors of this whole big 4-term polynomial. All right. I might have gone a little quick on this, but again, it's recorded. You could always go back and pause it and repeat it a couple times to make sure that you understand what I said. Okay. All right. More factoring. This was the factor chapter, wasn't it? But guess what? This wasn't the end of factoring, though, was it? All right. Didn't we do factoring even past this chapter? Yeah, we did this so that you can learn it, because we've already used it, and we're going to use it some more. This whole idea of factoring is a very, very important concept, this factoring. All right, let's take a look at this. It says factor this trinomial. All right, it's a ax squared plus bx plus c, isn't it? Now we're just factoring here. We're not solving, right? Remember we set this equal to 0 just recently, and we actually solve for x by completing the square or factoring or quadratic formula. We're not doing that. We're just learning we're just trying to factor this thing. And it is a trinomial, so if it's a trinomial, then I can just put my 2 sets of parentheses and figure out what's going to go in those parentheses. All right? Now look at the signs first. I always deal with the signs. They have to multiply to be positive and add up to be positive. So my only choices with my signs are they both have to be positive. Now look at look what we have here. The last term. Let's do the last term. The last 2 numbers have to multiply to be 5, don't they? All right. So I only have a couple options with that, don't I? 5 and 1, right? I could put 5 and 1 or 1 and 5, right? Those are really my only 2 options with 5. So that made it kind of easy. What about 8 though? I got a couple options with 8, don't I? I've got 8 times 1, or 8x squared. I've got 8x times 1x. I've got what? 4 times 2. I got 2 times 4. I got 1 times 8. Are there any other options? No, there's not. So I don't really have a surefire method. I kind of like to split it sometimes, you know. Instead of 8 times 1, yeah. I'll tell you what, if I was going to do this from scratch, I'd probably say 4 and 2. All right?
Other way around.
Okay, but this is what I would try, because I don't know what the answer is, all right? You've got the answer in front of you. Actually, I do, but I'm not looking at the answer in front of me. So, but if I was going to do this from scratch, okay, and I didn't know any better, this is what I would do. Now, how do we know if that works or not? Well, we got to FOIL it, don't we? We already figured out that the last one works, right? 5 times 1 is 5, and the first one works. 4x times 2x is 8x squared. So we already know that works, because that's how I, put those numbers in there. What I'm looking for is that middle term. So what do we have to do? We got to do the outside and the inside to figure out if it comes out to 14x. So let's try that. I've got 4x times 1, which is 4x. And this does work, Tiffany. What are you telling me? Okay, so 4x times 1 and 5 times 2x, so that's 4x plus 10x. What's 4x plus 10x? It's 14x, isn't it? So that does work, doesn't it? All right, so we're good to go on that. I don't have to try anymore.
Sorry,
Did you put 1 and 5?
On mine, I put the 2x plus 1 first and then
Ah,
2x
okay.
plus 5 on.
Gotcha. Yep, same thing though. You could have done that. You could have said 2x plus 1 times 4x plus 5. All right, and that's the same exact thing though, isn't it?
It is. I just forgot that. I
Gotcha.
just assumed you put them in the same order.
Right. All right, let's go with a different color here. What haven't we used? Let's go with this pink color. All right, 17. This says a perfect square. Wow, I even tell you it's a perfect square, so that's nice. I'll just write it down. Factor the perfect square. Now that should tell you something. What does a perfect square look like? A perfect square looks like this. It's a parentheses with a squared on the outside. Okay, this sign in the middle could be plus, could be minus, whatever. All right. So that right there is a perfect square. That's what my answer should look like. Something like this. Everybody understand that? So when I say factor the perfect square, you know your answer is going to look something like this. So that should be helpful. So let's write down the problem. It's 25m squared minus 70m plus 49. First of all, let's see if this thing really is a perfect square or not. I don't know if you remember how to do that or not. But let's say I take the square root of both of these n terms right here. What's the square root of 25m squared? It's 5m. What's the square root of 49? It's 7. If I multiply them together, if I multiply these two together, what do I get? 35m. But to understand if it's a perfect square or not, what do I do to that 35m? I multiply it by 2, and what is that? 70m. Is that my middle term? It is. If that stuff works, if that was a little test to see if it's a perfect square. Now, there should be no doubt that it was a perfect square because I told you in the problem it's a perfect square, didn't I? All right, so you didn't necessarily have to go through that. But if all I said was just factor and that was it, and you looked at this, you're probably thinking, hey, this has a potential of being a perfect square because I'm squaring something to get this and I'm squaring something to get this. How do I know if it really is a perfect square or not? I go through this test. Take the square root, multiply, double it, and if it's the middle term, then it's a perfect square. So, how do I factor this? Well, I know it's a perfect square, so I know it's going to look like this. I look to this term right here. That term determines what this sign in the middle is going to be, right? Because this one's always going to be positive right here. And now, let's figure out what's going to go in there. What is being squared to give you 25m squared? 5m, right? We kind of already figured out these numbers already, didn't we? All right, and what's squared is going to give you 49, 7, and that's it. That's all there is to it. That literally should take just a matter of seconds to do, just seconds. You didn't really have to go through all this because I already told you that it was going to be a perfect square. So there's no doubt that this is a perfect square. I'm not going to trick you and give you something when I say factor the perfect square. I'm not going to give you something that does not factor into a perfect square. Okay? That wouldn't be very nice of me, would it? So there you go. 18. Is it more factoring? Yeah, the rest of this is factoring, isn't it? So wow, a lot of factoring on this part of the test. This says factor the, I'll just write it down, the difference of two squares. And we talk about that a lot, don't we? The difference of two squares. So hopefully that makes a little sense to you. And this is probably just as easy as the perfect square. To tell you the truth, might be a little bit easier, I think. And I tell you, this is a difference of two squares. You don't even have to think about it. It is a difference of two squares because something is being squared to give you 81, something's being squared to give you y to the fourth, and something's being squared to give you 4. And you've got a minus in between. If that was a plus in between, could you factor it? No, you couldn't, all right, because there is no sum of two squares, but there is a difference of two squares. So you just have to remember how to set this thing up. Difference of two squares, both parentheses, they look the same except one's positive and one's negative. Remember that? So how do you figure out what goes first? Well, you just take the square root of that. What is being squared to give you that whole thing right there? 9y squared. And that goes exactly the same in both places. And what's being squared to give you 4? The 2. One's plus, one's minus. Notice they're not exactly the same. I remember distinctly when you guys took this test that a lot of people put plus for both of them. Or maybe it was this. Maybe it was a perfect square, and you went. Some people went like 5m minus 7, 5m plus 7. I don't know. It was one or the other. So maybe I don't remember so distinctly, but I do remember some people having some problems getting the two confused. A difference of two squares, they're not exactly the same, are they? One's positive and one's negative in the middle. That's a difference of two squares. It's always going to be like that. Okay? All right. I said it. I warned you. Okay? Hopefully you that made sense to you. All right, let's do number 19. This says factor the sum of two cubes. Sum of two cubes. Let me write down the little formula so that you remember what the sum of two cubes is. It's a plus b cubed. That's the sum of two cubes. And do you remember how to do this? What was the little thing I had you memorize? Same, opposite, positive. Remember that thing? So that's the sum of two cubes, or the difference of two cubes. Now, there is no sum of two squares. There's only a difference of two squares. But with cubes, there's both. There's a sum of two cubes, and there's also a difference of two cubes. The sum would mean there's a plus in between. The difference would mean there's a minus in between. Everybody got that? So how do we do this? The same, opposite, positive. So this is the same sign as this right here. This is the opposite sign, so it's opposite of positive, which is negative. The last one's always going to be positive. Okay? Same, opposite, positive. I think that's helpful, don't you? And you got to know what numbers to put in here. So what do you put in here? A and B. What do you put here? A squared and B squared. It's just a matter of memorizing this little formula. All right? And I told you when we first did it, you have to memorize it. And we used this just recently, didn't we? Just to solve for x or something like that. Okay, so we've done a lot with factoring even after this chapter. So that's very important. Okay, so let's write down the actual problem. It's 125x to the 12th. 125x to the 12th plus 8y to the 6. 8y to the 6. Now you got to look at it and you got to say, is that two cubes? I don't see anything being cubed here. But if you look a little deeper, delve a little deeper, you do have something that's being cubed. What is being cubed to give you 125? 5 is. That's right. 5 cubed is 125. What is being cubed to give you x to the 12th? So look, what to the third power is x to the 12th? Well, it's got to be x to the what? 4th, because the rule says you multiply the exponents. Everybody see that? So that's x to the 4th. And you must write it like this. It's very, very important that you write it like this. Plus. Now, let's figure out what's being cubed over here. What's being cubed to give you 8? What cubed equals 8? 2, right. 2 cubed is equal to 8. What about y to the 6? What is being cubed to give you y to the 6? Y squared, that's right. Because remember what the rule is. Exponent to another exponent, you multiply them together. So y squared to the third power is y to the 6. So look at this. Here's our main little formula right here. But how are we going to use this? Everywhere you see an A, what are you going to put in for it? A 5x to the 4th. Everybody see that? Because that's the whole thing that's being cubed. That's kind of like the a. So that goes where the a goes. Now, what's going to go in for the b? 2y squared. That's right. So that is going to go in for the b. So every time you see a b in this formula, you're going to stick in a 2y squared. So it's a matter of just plugging stuff into a formula now, isn't it? We've set it up. We figured out what our a and our b are going to be. And then now we just throw the stuff in here. So let's write it down. So there's one parentheses, and the second one's a little bit longer because I got 3 things in that one. There's my signs, the same, opposite, positive. Now let's figure out what's going to go in here. Now, just the a and the b go right here. So what is the a? It's just 5x to the 4th, isn't it? I don't have to do anything to it. I don't have to square it in the first parentheses. What's the b? It's just 2y squared. That was the easy part. What about this part right here? This is a squared, isn't it? So I got to take that a, this thing right here, and I have to square it. And I got to square everything. Square the 5, which is 25. Take x to the 4th and square x to the 4th. What's that? If you can't do it in your head, write it down. X to the 4th squared. What is that? X to the 8th. That's right, because you got to know the rules. The rule is, if you take an exponent to another power, you multiply the exponents together. Okay? Man, this problem just shows you how much stuff builds and builds and builds, right? Because we learned at the very beginning of the year those basic rules for multiplication. I always like to do the b next, okay? I don't know, it just kind of seems to go together. So let's take the b and let's square that. So it's 2y to the 2nd, 2y squared, and I got to square that thing. So if I take 2 and I square it, I get 4. If I take y squared and I square it, I get y to the 4th. And now what do? I got to do a times b. So this is my a, this is my b. I have to multiply them together. So 5 times 2 is 10, and then x to the 4th and y squared. And there it is. And that big old crazy looking thing is your answer. Most of you guys were pretty close on this, if I remember from the first time you took the test. But there were little tiny things in there that you got mixed up on. Okay, yep, it's probably your rules for exponents. It's probably that stuff right there is what a lot of you guys messed up on. So you got to be careful. You got to practice it. Okay, if I said that today, yes. You got to practice this stuff. You can't just sit there and say, oh yeah, okay, now I see what I did. I think I got it now. No, 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 you don't. Okay, you don't have it until you practice it yourself. You find another problem that looks very similar to this. You do that problem and you get it right. Then you can have a little confidence that you know what you're doing. Okay, we got time for one more, and that's all we have to do. Let's go with this deep purple color. This says factor by substitution. Factor by substitution. And here it is. It's 20 z to the 4th plus 3z squared minus 9. This almost looks like it's a quadratic, doesn't it? It looks like, it kinda looks like ax squared plus bx plus c. Kind of. Except, this is not an x squared, is it? It's x to the 4th. This is not just an x, it's a z to the 2nd, z squared. But if it was an x, watch what I could do. Remember this? I could say let what? X equal z squared. So if I do that, then this will look like a quadratic. So if I do that, if I do a little substitution, if x is the same as z squared, what's z to the 4th then? It's x squared, right? Plus 3. Now I already said that x was z squared, so I can just put an x right there, and then I put a 9. Now I could factor this thing. This looks a little more familiar. This looks like a regular, quadratic factoring, a trinomial factoring kind of thing. So what do? I do this. We're running out of time. Give me what this is, just so I don't have to go through the whole step here. I know one's plus and one's minus. You know what that is? I don't know. Well, not the z. Just factoring this. Is it 4 and 5? Is that what we use? So it's going to be 4x and 5x. Is it 3 and 3? Okay, let's just check, see if that's right. So I know the first and the last terms are right. Let's do the outside and inside. So that's negative 12, and that's positive 15, which is positive 3. Yep, that works. Good. No.
Z squared.
No, we're not done. We're not done. We're not done. Okay? All I did was factor this thing with the x. I'm not finished. Now what I have to do is take this and then plug it back in. Right?
Switch the signs.
Why?
Because if you do that...
It works. That's negative 12 and positive 15. That's positive 3. So it's correct. Right? I'm not missing anything. I think that's right, yeah. So now what we're going to do is we're going to take this thing right here and we're going to replace the x with what? Just a z squared. Okay? So what do we have? We got 4z squared plus 3. And then we have 5z squared minus 3. And that's your answer right there. It is the right answer, right? Yep. 4z squared plus 3. Yep, that's exactly right. Look at that. Perfect timing. Right before the bell rings, we're good to go. All right. Please do these problems yourself, okay? Don't just sit there and listen to me. Make sure that you practice these yourself, and don't just rely on what you heard in class today. You've got to do problems. Just because I'm not giving you homework this week doesn't mean you shouldn't be doing problems. You should have done problems last night. You should be doing problems tonight. All right? I'll leave that up to you.